Thank you for joining us today and welcome to the Construction Futures Research Centre webinar, How Discrete Event Simulation Can Improve Offsite Production in the Construction Industry. My name is Paul Davis and I'm the Knowledge Transfer Manager for CFRC. Before we move on to the main event, I would just like to tell you a little bit about CFRC. We're a project based at the University of Wolverhampton, which is part funded by the European Regional Development Fund. CFRC is aligned with the University of Wolverhampton's £100 million project to create a major construction research and innovation centre. Springfield, as you can see in the background to this slide, will be the world's largest construction education campus on a 12-acre site near the city centre, housing the School of Architecture and the Built Environment. The building is due for handover soon, and we're all very excited about this new venture. CFRC offers fully funded support to SMEs in the Black Country region, the aim being to achieve high standards of delivery in off-site design, manufacture and construction. The University of Wolverhampton employ academics covering all aspects of architecture and the built environment, and it's my job to pass on some of their knowledge to help industry. Knowledge transfer can also work both ways. Indeed, CFRC feeds information to industry, and industry can also feed information back into the centre. This can lead to research, the results of which can benefit both business and the university. CFRC offers various services, for example, Discrete Event Simulation, which will be discussed in detail shortly. Building Information Modelling, or BIM, which offers significant benefits to organisations who adopt it. BIM is a broad term describing the process of creating and managing digital information about a built asset during the design, construction and operation of that asset. It's not just about creating a fancy 3D model. BIM is about providing all of the information required for the lifetime use of that asset. For example, during the life of the building, 75% of the costs are on operation, and having access to a BIM model can help cut costs. BIM allows for virtual models to be created collaboratively and tested in the virtual world, ironing out problems before the construction phase. CFRC can offer support on BIM Level 2 compliance. We can also offer support right across the supply chain. For example, a soon-to-be-started research collaboration using AI to optimise a modular house design so that it is cost-effective to manufacture, carrying out laboratory tests on components used in the built environment, and advice on introducing BIM into an organisation. CFRC employs digital techniques such as AI, VR, and AR to help develop more efficient workflows. At CFRC, our focus is on off-site construction, and the aim of the project is to improve the efficiency of the construction sector. To do this, we hope to develop new methodologies to simulate processes in the construction and infrastructure sector, and to propose efficiency improvements, especially related to housing delivery through off-site or related techniques. Some people ask, well, what do we get out of it? Well, as a university, research is important, as already mentioned. And the underlying research focus of the project is to collect real-time data from industry, develop real-time process simulations, so that we can perform analysis on improving processes within construction supply chains. But by undertaking this, the project will foster a process improvement system for the companies involved, which will lead to the development of groundbreaking methodologies for process simulations and productivity gains for the region, impacting housing and also major infrastructure projects. As mentioned earlier, one of the main pillars of our offering is to provide discrete event simulation for our clients. Using modelling software, our researchers are able to simulate an entire process right through design, manufacture, installation and operation of built assets. Try different scenarios in the virtual model, see the impact on the business before experimenting in what could be the expensive real world. If you're interested in discussing how CFRC can help you or anyone in your supply chain, please get in touch. Our contact details will be shown at the end or pop up a message in the chat box. Okay, it's now time to introduce you to our main speakers for today. In fact, we don't have one, we have two doctors in the house. Dr. Emmanuel Daniel, Senior Lecturer in Construction Management and Course Leader for the MSc in Offsite Housing Construction, and Dr. Muhammad Rana, Lecturer in Construction Management. Thank you very much, and over to you guys.
Thank you, everyone. Welcome. I will be sharing my slide with you shortly and to give you the overview of our presentation. Okay, thank you once again. And Paul have introduced me, but just a quick background about myself and what actually brought me into this area of research. I'm a construction manager by training. I'm a chartered construction manager with the CIOB, and my experience in the industry while practicing as a site engineer, site manager, when I look at production process on site, and what baffled me more was the non-value adding activity. And this motivated me to do my PhD in lean construction, looking at how to improve production processes, and which have actually expanded to the concept of offsite construction. So just to give you a context about myself and what I'm passionate about, and which is what we'll be sharing with you. So with regard to the overview of the presentation, the first session, I will be establishing the theoretical basis for discrete event simulation and simulation in general. I will also talk about production. What does that mean in relation to offsite, and why do we need it? And my colleague, Dr. Rana, will be showing us how do we develop this model, how do we validate it, and he will be showing us some practical case studies where these have actually impacted cost and time. Now, I want to say, as the presentation goes on, you can write your question in the chat box so that you don't forget. So at the end of the presentation, we'll be looking at your question, those that relate to the technical content or questions that relate to the kind of support you have from CFRC, they will be taken care of. Yeah, so to the presentation, as we are all here. I know we have interest in offsite construction in a way. That is why we are here. But just a quick outlook of what the offsite construction looked like, most importantly, during the COVID-19. And these are the news. And so there is increased quest for it. You can see outlook for modular construction post-19, and both the private and the public sector, there is increasing interest. And more importantly, especially if you are based in the UK and you've been listening to the various government statements, you would have had the kind of support that government is actually intend to give to companies who want to adopt MMC. And as we see that this is going to be a new normal, looking at the present condition which we have faced. So there is a bright picture for the offsite construction industry in many years to come. But back to the construction industry itself, when we look at the construction industry from innovation perspective, what we've seen over the years that the industry is less innovative. And I think if you've read the McKinsey report, they actually compare the construction industries is just above agriculture and hunting. So, but the question I ask after reading this report is this assertion true? Is this view totally accurate that the construction industry is not innovative? And my next slide will actually throw more light on that. When I try to do some research to understand where are we with regard to innovation and in particular simulation, and I came across the work of Professor Paul Theosi, who is among the first person that have a PhD in civil engineering management from Stanford. And what he looked at basically was to understand how a simulation is used in the construction industry. Now, 1963, today we are in 2020, and now we are talking about how do we apply a discrete event simulation to improve our processes. And so coming to my initial question, what I would say is it is not really true that the construction industry is not innovative. Rather, they are only being slow in adopting innovation. For those of us who were in the last webinar, which Dr. David did, we look at various emerging technology used in the construction industry. So looking at the concept of simulation, which is the focus of our presentation today, simulation is actually a decision-making and approach to enable us understand the process we want to go into before the actual implementation of that process, basically. That is what the concept of simulation is about. It could be on-site construction process. It could also be in a factory environment. But you try to model this process and identify the constraint and using what-if scenario, which Dr. Rana will be demonstrating that in the second session of the presentation. And so with this, we could simulate factory process or on-site process to see how they can be improved. But the question now is, what is the relationship between simulation and production process? Now, we discovered that there are a lot of variability in the production process. When I say variability, uncertainty. And the best way to track this variability is actually to simulate it, to understand it, and see how to address them. Also, when you look at the interface between various activity, there is this demand for space, resource, and time constraint. How do we reconcile this? So we use that to manage the production process effectively also. And then looking at the mainstream scheduling tools, which the critical path method, which is actually used in developing program. What we've observed over time is that the critical path method, we can use it to manage short-term planning. And so there is a need for us to innovate and develop a more realistic approach to overcome this. Most of our Gantt chart is there on the wall, and what is going on site is actually different from what is on the program. So those are the kind of inefficiency we are seeing within the construction process. And also offsite production process is made to order, and that put a lot of demand that we need to be accurate in what we do. And then also when we want to relate what is happening in the shop floor to what is we are installing on site, how do we simulate this process? When there is a demand for a particular component, how do we know that this is the capacity we need to increase on the shop floor to meet the demand on site? So this process can be simulated, and talking about change in design, which is what the if scenario does. So those are the key roles simulation play in the production process. So just as I said, that the concept of simulation is not new. Okay, it's a normal practice in other sectors, but it seems not to be common within the construction industry. We all know that space agency applies simulation to assess their flight file, and then pilot, they are trained using simulators prior to flying a plane. So these are common practice. And then look at scientists, they simulate their processes. Maybe the nuclear, those that work in the nuclear industry, they simulate every operation. Then the question is, why can't we simulate our process to understand the defect and improve them better? And in terms of production line, those are key things we simulate. What happened between the various production line? How much time do we need to stay at a particular production line. Those processes can be simulated and see how they can be optimized. So why do we use simulation? Yeah, the key things which I believe you already have in that field from my presentation so far. It enables us to articulate, to distill our thought and articulate the problem clearly. So you are not under pressure because you are visualizing it. You're able to articulate the problem and see the dynamics, and you have new insight. From the new insight, you'll be able to document the required process to address the problem. Also, it enables us to examine what are the best strategic options to use to address this problem. And one great opportunity that simulation offer is the opportunity for you to collaborate. So when three professionals, you look at the simulation result, you'll be able to decide the best option to use to deliver the process. How about developing strategy from management perspective? What action they need to do to make a business decision? And more importantly, you'll be able to optimize your resources, okay? So we have various types of simulation. So we have discrete event simulation, agent-based. So those are key, the various types of simulation. Now, for the purpose of our presentation today, our focus is discrete event simulation, and which is applied on construction project. Also, agent-based simulation has application also. So the discrete event simulation is all about trying to make decision in relation to a particular process. So usually it involves generic entities following rules dictated by system agent or process, such as this as server. They do not make decision on their own. It is relevant to routine processes such as your production line in the factory. So the discrete event simulation enable you to simultaneously analyze any production system that involve the use of space, resource, and energy. So the focus of discrete event simulation is process efficiency. And agent-based simulation is a higher level because it has the capacity to model the behavior of the individual agent that are in the system. Of course, this is beyond the scope of our presentation today, but that's to just give us a view about this various types of simulation. In terms of example, how does this discrete event simulation operate? A simple example I will want to give is actually maybe you are modeling a queue in a bank. If I'm modeling a queue in a bank or a service on the production line, what I want to do in discrete event simulation, your focus is actually to understand what is happening when a customer enters the queue, and then to the point at which the customer goes out to the queue. So we assume A is a customer and has come to the queue. So the focus of discrete event simulation is the discrete activity that happen, not just the activity that happen per second, but the activity that happen between this point. So we can use this to model a shop floor, maybe for production of maybe roofing system, which is one of the examples I'll be showing us shortly. So maybe this is a roofing system. You are trying to set up a factory. So your first production point is the raw material. The second production point, maybe you have this material they are being machined into bar. Then you have the storage part. You have the roofing product station. You have your boarding station, your loading station. So what happened is through the discrete event simulation, you'll be able to simulate the production capacity of the steel cutting machine. So you know what the machine can produce. Also, you'll be able to recognize the idle time at each station by simulating different scenarios. you also be able to simulate the capacity of the human resource that may be required maybe at the boarding point. So those are the kind of information you'll be able to get. Through this, you also be able to identify how many machines and workers will be needed for optimal production. How many assembly stations do you need? So all this is being simulated before you even create the factory itself, and then you have optimal value. So there are various applications to this, and there are key questions you ask when you try to simulate a process. So you can use this for capacity planning. And in such case, you may ask how many machines will be needed to meet a new order. Maybe you are producing wall panel and you have an order. So how many machines do you need? So you use that for capacity planning. How about project cost justification? So you may want to think, if we reduce the defect rate in the production of a bathroom pot to 2%, what will the reduction in the inventory and rework cause the project to save money? You need to think. So am I going to make any profit if I make a change? And so you can simulate this process. Also, you could also use it for technology planning. So in this case, you may want to think, if you have a crane or other machine, if you have this service time to be reduced by 20%, would the technology worth the cost? So if you have a crane that is not working 20% of the time, and you look at what you need to produce, what comes to your mind is, do you really want hiring that machine to come to crane to come to site to work? And then in terms of strategic planning, is what is the long-term implication of maybe producing just one component of Offsite, maybe wall panel alone? So what would be the long-term implication? And so this is also used in military. So maybe you are going to war. What would be the implication of using only your air power to fighting your enemy? What is the long-term implication? So those are strategic plans that you can make. And then finally, you'll be able to use this to test and plan your design. And the kind of question you ask, maybe for instance, you are producing roofing material. You want to have, what should be the gauge thickness of the roof for it to meet the performance requirement? So you'll be able to test this before the actual production. So having said that, the simulation has a lot of benefit for us, as we'll be seeing it in the second session of the presentation. You'll be able to, the condition can be controlled lots more effectively than reality. So you don't want to the risk of trying to do a work study, or it will involve money and risk and doing all of that. But this, you do it on the system and you have your results, you make decisions. Simulation of a longer period of years, months can be done in few minutes. You can understand the process within minutes. And if you want to do a work study on that process, it takes you days, weeks, and months. It's fast and lots cheaper to model than to disturb. That does not mean that there is no disadvantage in that. So most of the answer you obtain using simulation has some sort of probabilistic accuracy attached to them. So it's based on probabilities. Those are some of the limitations. The amount of the information needed to actually develop the model is enormous. So those are the things we need to have at the back of our mind. So that is actually bringing me to the end of my presentation. So my colleague will take over, but before then, I will want to just introduce the master we run at the University of Wolverhampton, the master in Offsite housing construction. Now, some of the information we are presenting today are some of the things the students engage on the program. This course is open to international students, home students, and as I showed us in my first slide, that there is a big market for the offsite construction. So this program is an online distance learning program. It's 1 year full-time and 2 year part-time. And so you can get on this program from any part of the world Currently, we have some of our students from the state, some are based in the UK. For the September start, the application is already open, and we have some application in already, and we're expecting some of our students to be coming from Hong Kong, some from Africa. And so that is the program. On this program, you will be learning some of the stuff we've talked about here, but also you will learn about the application of BIM in Offsite, design consideration for Offsite, discrete event simulation, which we just talked about, automation and 3D printing. Those are the range of issues that is covered on this program. So the application for the September start is open. And so if you are interested in this, you want to develop your skill and your knowledge in this aspect, so it's a great opportunity to key in. And if you want more information, of course, I will put more information about it in the chat box. Thank you very much. So I will stop sharing my slide now and allow my colleague, Dr. Rana, to continue. Thank you.
Thank you very much, Dr. Emmanuel, for setting the theme. Let me share my screen with the colleagues. Okay, so this is me, Dr. Muhammad Rana. I work with Dr. Emmanuel and Paul at the University of Wolverhampton, and a lecturer in construction management. I did my PhD in simulation modeling and lean construction while I was working with Highways England on their projects. One to mention was A556, which is the junction between road between M60 and the M6. Very quickly coming to the types of simulation modeling, Dr. Emmanuel has rightly said there are various paradigms of simulation modeling. How do we know what's the difference between them? Which one is the right type of paradigm for us? So if we look at this picture, discrete event simulation lies on the left bottom to middle side. And what are the parameters? So the higher we go, the abstraction level is higher, which means we have less details, we have more assumptions, we are talking about macro levels, and we are trying to make strategy. So we are looking at things from a strategic point of view. On the middle level, we have some sort of high detail. We are talking about meso level. We are doing things with tactical stages. And at the very bottom left, we have low abstraction, which means we have very high amount of data coming in. We are talking about operational level. So this is where discrete event simulation tends to lie. Now, what does that mean is, so if you are talking about system dynamics on the top right, system dynamics has feedback loops. So if we want to look at the impact of flood on an economy, and we do not know how big the flood is and what the impact might be, so we are talking about a lot of assumptions. So if we assume a flood of this level hits the city, what will be the impact? We simply draw loops which are connected to each other. It gives us some sort of idea of what the damage will look like, but we will not have 100% numbers. So it is quite similar to what WHO has been doing with modeling COVID-19. So they cannot give us exact numbers, exact figures of how it is going to act, when it is going to stop, what the damage will be like, but it gives us an idea at a strategic level to start preparing for it. Agent-based modelings come in between, which is a mixture of both system dynamics and discrete event simulation, where we not only look at the system itself, but we can also look at the behavior of agents in between. So if we want to, for example, simulate a person walking into the hospital, the stages he will go through, the amount of people that will greet and meet him. So we are looking at the system itself as well as that particular person. We are looking at the system from his point of view, how he is being treated, what changes is he going through, how long is it being taking. On the very left, we have discrete event simulation modeling. So this is more about processes, flow charts, networks, resources, so quite operational level detail. So since there are quite a lot of benefits of discrete event simulation, there are some disadvantages as well. To start with, it requires quite high level of detail, which means even if we are simulating a coffee shop, which means a person has to stand there, look at data like how with a stopwatch and the chart how many people are entering the shop, how long does one person take, how many types of people enter the shop. So there are people on their own, there are people with children, there are people with special needs. Record very accurate level of data about each category of person. How long do they stare at this window? What do they pick from there? So if we have this level of detail, which is not very hard, not impossible to capture, but it obviously takes time. So it is about the mince machine. We put rubbish in, it will get rubbish out. We put good data in, we will get, it will spit out good results as well. So this is the fundamental difference between three different major paradigms of simulation modeling. Then there are other modeling types like traffic simulation modeling and pedestrian simulation modeling, liquid, fluid simulation modeling as well. But today we will mostly be talking about the discrete event simulation. Since it is an introductory session, we are talking about the process of how we make a simulation model. We will also look at how we validate a simulation model. So the first stage in creating any sort of simulation model, regardless of what is the level of detail, what is the paradigm, system dynamics, agent-based, or discrete event, the following two processes that I will demonstrate to you, the process of simulation modeling and the validation will stay same for all these three types. So the first one obviously is the problem formulation. If we do not know what the issue is, we will never be able to choose the right type of paradigm. We will not be able to choose the right software that we are going to use, and we will not know what data are we collecting and how do we do that. So the first key critical step is to define the problem, and the aim of this step is to outline the objectives of the whole process and precise queries that a simulation model should answer. So what are the questions that we want our simulation model to answer? It is quite critical step, and the lack of attention at this stage may lead to quite a lot of inaccuracies and even failures in the work later on. So our research should be specific. If it is vague, if the questions are quite ambiguous, it will definitely lead into wrong results, which will lead to bad decisions, and it will waste quite a lot of time of all the people who are being involved in this process. It is not easy to state a problem precisely, but and to quantify it. But with experience, with the right people on board, this can be done quite effectively. The next step here is establishing independent and dependent variables, which we do that in setting objectives and project plans. So we create a project plan with all the resources that are in the system, the questions that we are answering, who's going to do what are the variables in our system, which of them are depending on something, which of them are independent. So self-reliant variables, they reflect system parameters, whereas the dependent variables, they consist of performance standards, they depend on something. So it is quite important to link with each other. We will see later on how these logic diagrams are made in simulation model and how they rely on each other, how they depend on the activities before and after them. Third step is model conceptualization. Here at this stage, we create a conceptual model in our head. It can be a mathematical model, it can be a theoretical model, or simply a conceptual model where we assume how it is going to look like or how it is going to answer our questions. So sometimes we may have a question in our head and we do have a tentative potential answer as well. So this is that answer which we have in our mind. Based on our queries, we try to create a simulation conceptual model, and then we try converting it into reality, converting into the actual discrete event or 3D model. So in this stage, it is a good practice to develop a theoretical or a conceptual model before we start making the actual model. This way we will know how the real system will look like, what sort of data are we going to require, what resources will we need, do we need a special programmer, do we need special people to help us with. So conceptual model is set up with the help of logical and usually mathematical relationships, which are related to the structure and the overall system, the components of the system. Here we can clarify the model components, their relationship between each other, the objectives, the algorithms that we are going to use, and most importantly, the assumptions that we're going to make. In any sort of simulation modeling, we use quite a lot of assumptions. If they are not accurate, if they are too vague, too wide, there will be a lot of inaccuracy or ambiguity in the simulation modeling, which will lead to bad decision making, which we do not want. So it is quite important to set these things up at this stage. Now that stage is model building and data collection. Here we start converting this conceptual model into the actual model. And the first step there is collecting the right amount of data, right sort of data. So collecting data is quite a challenging part, and there can be many unforeseen encounters in acquiring the right amount of data. Sometimes it is just not available in the desired formats that we are looking for, or sometimes it is not in that level of detail which our simulation model or the software requires. So how do we convert those? How do we negotiate with that? So first step there is establishing the necessary model parameters so that we know what are the procedures, what the system layouts are, what sort of data are we collecting, and why. Next step can then be creating and validating a computer-based model. So the model translation and validation. So we create a computer-based simulation model using any software. There are various free software, there are paid software. Some of them can be very expensive, up to £3,000 a month, depending on the operation that we are using it for. So a model is built by using simple steps in the beginning, and then it automatically starts to become complicated at the end of project. So we start linking small steps like a person entering the queue or a component entering the queue, going to the combiner, two of the components getting combined, then they are going to handling stage. So we start with one step each. This is why it's called discrete event. We make small discrete events, and at the end, we get a nice 3D system, which is a complicated, complex simulation model of the actual life. So it is mimicking the actual life process, whether it is a Amazon warehouse where thousands of processes are happening at the same time, or whether it is an airport system where hundreds of processes are happening at the same time seamlessly. Once we have created a simulation model, next step is to verify and validate it. And obviously, then we jump to start what if scenarios. One of the key reasons why we use discrete event simulation modeling is the ability to perform different what if scenarios. These what if scenarios we cannot perform in real life, like Emmanuel said, because of the time restrictions, health and safety restrictions. I will show that in a later slide as well, or any other legislative problems which will restrict our ability to do these what if scenarios. What if this happens? What if that goes on? What if the machines break down? What if the system collapses? So all those scenarios we are able to practice. So it is then very important to perform this simulation modeling. After we have verified our conceptual model, we do different replications, different warm-up periods. We run it for different lengths of time just to get more accurate results. So different experiments, different what if scenarios are experimented at this stage, so that when we validate the actual 3D model, the final results we are getting are accurate. So we try to run as many what if scenarios as we can. We try to run it as many times as it is possible. In a real life, if we are running a system, we cannot foresee the results before it is finished. However, in simulation model, if the model is going to run for 24 hours, we can simply fast forward it. So that 24-hour process will be finished within 10 seconds or 20 seconds based on the computational power. And that will give us the ability to look at the results of that 24-hour process just in 1 minute. And once we are done with running these what if scenarios, it leads us to the documentation and reporting. Here, the decision is still up to the executives to make. If we are buying a new set of machinery, we have done simulation modeling. Shall we procure it or not? Is it worth buying? If we are preparing for a pandemic, we have done our simulation modeling. Here we do the documentation, leave it to the experts or to the executives to make a decision on what they suggest. So Final step is analyzing and validating the results. So once the simulation has been done, the results are to be examined and then approved by someone who is knowledgeable. If the results of the model are aligning with those of the conceptual model that we created here, it means the computer model has been made accurately, the data has been collected in the right way as we wanted to. Various what-if scenarios are practiced in the computer-based environment, and they have to be validated by the people. Now, why do we need this validation? We are talking a lot about it. We are humans, we make mistakes in collecting data. The computer won't make any mistakes while doing these runs. But what if we have made an error by putting the wrong logics together, or we have made an error, we have collected wrong sort of data? Simply, we have used different units. So if the simulation software use meters and we have used centimeters, that is quite common. We have used inches and we did not know. So the results will look quite different. So it is quite important for us to validate our model, take it to experts, do a focus group, ask them, what do you think about it? Does it look right to you? Or we can do a theoretical validation as well. So this is how a back end of simulation model looks like. This is Simio, a software called Simio, which I used during my PhD. We created a simulation model for earthworks. So we were digging. So this is on the site of A556. We are not using the pictures of the road itself, so you can only see the numbers and the excavator. Excavator has a lot of dump trucks standing in front of it. So we were doing quite a lot of cut and dig operations. So we were cutting soil from one point, taking it, dumping it somewhere else so that we can have a straight road at the end. On the left, we can see the logics. So we start the process with begin. We assign operations to different machines. So if it's a dump truck, a driver will sit in at this particular time. He will arrive at the site. Then he has to drive it to the excavator. The excavator driver then has to start digging, fill the sand or soil up in the machine. Then he has to make a decision on which dump truck is in front of me. If it is filled, which one should I go next? So we have to collect that sort of data in that amount of detail. Only then we will be able to get something which is visible on the right. We can see the average truck utilizations, we can see excavator utilizations, the idle time that they are waiting, doing nothing. What if they break down? We see here the excavator is utilized 100%, which is quite above its capacity, and if it breaks down, it can be a problem. So this is how the back end of simulation model looks like. The front end obviously is a 3D nice model, which we will see. Very quickly on how we validate a model. So if we can take it to the experts, we can show it to people who have been in this business, people who know this very well, they can give us some feedback. So that is our focus group validation, which is very useful. What if we have to validate it ourselves before we take it to the experts? We can do it theoretically. So here it says artifact evaluation. Artifact can be any model, any set of recommendations, guidelines that you have created to address a problem. That is your artifact. So this model, which I really like, have adopted from, I can send a link later on, the people who have developed it. So it helps us looking at a simulation model from different point of view. So what was the goal of it? A goal here describes the purpose of developing this model and how useful it is. So we can answer these questions ourselves, whether it ticks the box or not. So its effectiveness, its validity, generality, they can characterize it. Efficacy or efficiency is the extent to which the artifact or the model achieves its goal or produces its aspired outcome that we were looking for. Validity is how valid is this model? Is it similar to the conceptual model that we thought of before we started? How general it is? What it means is that can we generalize it? Can we use it on different projects? Second aspect is the environment. The environment it is created in, also the environment within the system, within the simulation model. So environment dimensions can include the organization, people, or the technology. Hence, it is the criteria for the dimension should test the consistency of the artifact within the organization. as a whole. So what comes in environment is the consistency with people. If we have created this software or simulation model, will people use it with consistency? Is it easy to use? What are its side effects? How will people understand it? Is it easy to understand? What are the different utilities of it? Environment in terms of technology is the harnessing of recent technologies. Can it be integrated with other systems? For example, BIM model, yes, it can. What are the side effects? Do we have to buy something extra? Do we have to hire other people? And finally, the consistency within the organization. So can the system as an organization adopt it, and can we make decisions based on this? Third one very quickly is the structure of the model itself. Now, once again, this can be any model, discrete event, agent based, or the system dynamics. So we can validate them through this criteria. So how about the clarity? How simple it is? What is the style of it? What is the level of detail? Will people understand it quickly? What is the structure of it? What sort of data have we collected? So these are all the tick boxes that we can do ourselves to ensure our model that we have created is accurate, it is right. Second last is activity. How complete is our model? How accurate it is? How does it perform? How long does it take? How many runs have we done? And finally, the evolution. How robust is our model? Will it comply with all the coming legislation? Will it comply with all the new technologies coming in? New criteria is coming in? Will it integrate with them? Will these software talk to each other? So if we cannot do a focus group, we can validate these simulation models or any artifact that we have created a set of guidelines through this theoretical process. Why do we simulate? Dr. Emmanuel rightly said, it's simply time. Sometimes it just costs too much. There can be restrictions. For example, we worked with Highways England on this project where we were resurfacing a road. We cannot shut more than 2 lanes, even if it's a 4-lane road at one time. We have to take permissions months in advance. Now, when we said that, what if we have 2 planers, 2 pavers, 2 sets of machinery together to experiment? It is not easy simply to have 2 sets of machinery together to do experiment because they are expensive to get. We need extra set of permissions. We will need extra set of people. So doubling everything just for the sake of experiment is simply not worthy. So Highways England came to us saying, we have these scenarios in mind. So we have this conceptual model. Can you convert it into reality so that we can experiment it? So this is what we have done. So sometimes it is not worth doing it in terms of risk, limitations, legislation. We have had some example of what CFRC did for some of the SMEs. I'm aware of the time limits. Very quickly, we created a simulation model for a company. We realized the combiners and the employees working there were working above their capacity. So it was a glass manufacturing company. So the combiner were working for 98% of the time, so which is way above the ideal time. And the resource, which was the only employee shifting parts between the different conveyor belts, was working 99% of the time. So after we have mapped it, after we have created a simulation model, only then we realize that we are relying way too much on this machine and this person. So we went back, did some changes. It is as simple as that. While the system is running, or we can stop the system, make these changes. So we were controlling here the input, the amount of raw material coming into the system. We simply changed that, reduced it a little bit. So we were using random triangulation here. And the results, we see the utilization of that employee has gone down from 99% to 90%, which means that he will have enough time to take breaks if he needs to go to the loo or whatever. What if the machinery simply breaks down? We are not using anything above 90% now. So the combiners are working within their safe capacity, safe limit, 86%. Here, it will also give us the ability to make a case for hiring a new person, hiring an additional employee. We can make a case that this person is working for 90% of the time. So why not we split it into 2, or why don't we automate this process? We would not get these insights without creating a simulation model. We just look at it from outside, everything seems smooth, everything seems to be working, unless we break it down, model it, and then we are able to see these numbers. Last slide before I finish, very quickly, I know there are a lot of advantages where simulation can be used, but I would like to show you some scenarios where simulation cannot and should not be used. So it is not really useful if the problem is relatively simple. So if you can experiment it in your own complex, in your own time, you do not need to create a model. Like I said before, the amount of detail that goes into it, the skills that you will require, the help that you will have to get from other people can be expensive, hard to get. So if you think that it is easier and cheaper to experiment it physically yourself, then there is no need to create simulation model. Simulation model relies on very accurate data. So if you think there are more assumptions and it is hard to get that data, there is no point creating a simulation model. If some specific resources are not available for the modeling, it will not give us the best results. In simulation model, we try to get the optimum results. If anything is missing, which is critical to the process, it's better to leave it. Sometimes an issue can be resolved analytically, logically. So how about we try to solve it logically, analytically first, or physically? And if we see it is complex, it is hard to do, then we jump to creating the simulation model. Finally, if a system is too complex, if it is involving a lot of independent variables which are in hundreds, and the system will take a lot of time to build. Sometimes it takes months to create a simulation model. It is simply not worth it. So then we have different ways of breaking it down. We use agent based on some part, we use system dynamics on some part. And if we cannot verify it, we cannot validate it, then there is no point spending so much time on it, because the results that we will get out won't be trustworthy. So thank you very much. This is all from me. This was an introductory session, so we had a lot of cover within this session. Over to you, Paul and Emmanuel.
Thank you, Rana. Thank you, Emmanuel, for two superb presentations. Really, it's over to you guys now. If you've got any questions, there's a couple of ways you can do it. You can raise your hand, or you can pop it into the chat box. So, do we have any questions on discrete event simulation or CFRC?
Rana, can you see the question?
Yeah, so there are different types of software depending on what is the purpose of our model. So if we want to look at things on a strategic point of view, for example, how I mentioned WHO is doing with the pandemics, they use system dynamics softwares. Whereas we are talking about operational level agent-based modeling, we can use software like Simio, SIMIO. I can write that in the chat. So let me send it to everyone. So the software are Simio, Qasim.
We have a question on BIM tools. Would you like to take that, Emmanuel?
Rana should go for it now.
Yeah, so BIM tools can be definitely be integrated within the simulation model. Simulation modeling has evolved from black and white interface of DOS to a 3D model which looks very real. The examples we have shown you were still quite animated, but if you look at the new Qasim and Simio presentations, they look quite realistic. BIM can be integrated very well into it. In fact, we did not have enough time to show, but the A556 road that we worked on with Highways England, we have had the BIM model from Costain, who was working there. We simply integrated it with the simulation model. We had exact numbers, exact figures of how long is this road is, what are the dimensions, how many people are involved. So that was quite accurate, and the results that we got out of the simulation were also very accurate, and they were validated very quickly, simply because we integrated the actual BIM model into our simulation model. So sometimes it is possible within the software itself. Sometimes we have to go to third party, AutoCAD and stuff to integrate both. But yes, it is possible, and it is done almost every day.
Thank you for that. I mean, if any of you guys are interested in discrete event simulation, how we can apply it to your business, by all means, get in touch with us. I'll be putting, you can see contact details on the screen, and I'll put my email address in the chat box shortly. We have another question on the name of BIM tools.
Emmanuel, would you mention any BIM tools that we are using?
Yeah, within the BIM model itself, so you can look at the processes. So what the BIM does is it enables you to the various design components to interact, and that alone will enable you in terms of producing the component. So if you are producing M&E component, you are producing and to be used in an offsite project. So you should be able to use that to ascertain the interaction between the various components you want to use in the project. So when you talk about specific, the name of the BIM tools, I think is the model itself. So you model the process in the BIM, and through that you'll be able to visualize how the components fit together.
I hope that answers your question. Do we have any other questions? We've got a couple of minutes to go, so got time for a couple more questions if anyone has anything.
I would comment, Paul, today's session was quite introductory, where we talked about what simulation model is. Some people, some attendees may already be aware of it. Some were possibly looking for a different, for a more advanced level of detail. So if we see interest, we can make it continuous process. We can have a series of these talks where we invite more people. We show the live case studies that CFRC has worked on, how we are helping people, how we are helping SMEs.
Yeah.
And we can also talk about the processes in more detail in the coming sessions if we see interest from you.
We have a question from Louis there.
So how might this discrete model integrate
Emmanuel, would you like to go or so?
Yeah, Louis, you're asking how might this discrete model be integrated into BIM process, making your model information available and obtained in the common data environment. So what happened is, yeah, when at the design stage in offsite construction process, so there is this, because you make what you call design to order. So you, as I said in the initial explanation, so you have the order, so you are making to order, and that means the supply chain, they actually involved in the process, and the information you need to include in the common data environment will actually be obtained from the various stakeholders that will be involved in the design of that component, which you can integrate into your BIM model and check if this component fit together effectively.
I hope that answers your question. Well, we're just about out of time, folks. I'd like to thank everyone for participating. And again, I'd like to thank the presenters, Dr. Emmanuel and Dr. Rana, for fantastic presentations, much appreciated. And finally, if Construction Futures Research Centre can be of any help to you guys, please get in touch with us and we'll see what we can do. Thank you.
Thank you very much. And for those of us, you want to know more, you want to learn more about how this works, how the BIM models work with the offsite construction. Of course, this is what we do extensively on the program. So it's worth considering becoming on our master in offsite and housing construction, where you have one of the tags actually to develop the BIM model using offsite and how this fit together. So it's something you would want to consider. You can also get in touch with myself or Dr. Rana in your.
Thank you.